Hello everyone, I hope you're having a good day. This lesson is going to go over one con assignment as well as a little bit of review for you to do a worksheet. So the first con assignment is about interpreting graphs of these functions. So we're going to have to read through each question and kind of match up the pieces they're talking about. So they might mention something about like the y-axis. It could mention the x-axis or the x-intercept where it crosses. It could talk about a relative max or min, so min thinking of high points or possibly low points. And it'll probably talk about either increasing or decreasing, something going up or down. So we're just going to end up matching up each situation here. Important thing is to read the context of the question so you know what to look for. So it says Jan threw a javelin. H of D models the height of the tip of the javelin in meters. So we're going to talk about height is here. As a function of its horizontal distance, so the distance thrown, following the throwing arc. Match each statement the feature of the graph that mostly corresponds to it. So it's first talking about x-intercept here. Might be good to find what is the x-intercept. This function intercepts the x-axis at 90. We see it touches right there. So probably going to match up x-intercept to number 2 that says Jan threw the javelin to a distance of 90 meters because that 90 was the x-intercept. Then we have relative maximum or minimum. So remember that's either going to be talking about the highest point or the lowest point. Now usually when we're talking about a maximum or minimum, you're going to look a lot at its x and y value. So I see that it reached its height right here, and that was, it went 14 meters in height, and it was thrown a distance of 40 meters. Well, let's look at the point here where it says the highest point the javelin reached. That word highest indicates we're probably talking about the maximum or minimum, so we should match those ones up. And that should leave the last one to match up. Increasing or decreasing. So we should see some sort of shift. It says the javelin began its descent. Descent, that's another word for decreasing, after the 40-minute mark. So that would be the third one. All right, we're going to look at example 2. Dina discovered a water leak in her basement and called a plumber to fix and drain it. W of T models the amount of water in the basement in liters, T hours since the leak began. So we have hours here. We have our water in liters here. We're going to match each of these up. So the x-intercept. We technically have 2 x-intercepts this time. I mean, it started with 0. She used to have no water in her basement before the leak began. And she had water in her basement until 9 hours in. So we see the time is 9 there on the x-intercept. I'm going to pick the only one that mentions 9. So the x-intercept should match up to this one. The plumber drained all the water out after 9 hours. The relative maximum or minimum, we're talking about the highest or largest something happened. So that high point is going to be right here. And we see that came with the largest amount of water we had was 70 liters before it started going down. So we are going to match up the relative maximum minimum with that highest point. And that should leave the last ones to go together, increasing or decreasing. Over the first 5 hours, the leak just got bigger and bigger. That means it was increasing. So make sure when you go to do your con, you're reading through each of these scenarios to figure out what goes together. All right, this next part is partially a review. So we've already talked about the domain of a function. The domain are going to be your inputs, the x values. The range of a function are your outputs, the y values. So they want you to just list out what are the domain, so your x values. I left out a parentheses there. And then what are your range, your y values. Now I will say typically when people list these out, they're going to put them in like least to greatest. But if you don't, that's perfectly fine. So I just want to list out all of my x values. So that would be 0, 2, -8, 4. And we do use curly brackets around them to show that's the set. Range are what are my y values. That's going to be 5, 7, 10, 3. Again, it'd be better to put them from least to greatest. I'm going to do that on the next one just so we can kind of get used to that. So example 2, what are my x values? We have a -1, and then a 2, 3, 4. Let's see, I put them in order from least to greatest this time. And then my y values, I have a -7, -4, 6, and 12. You should be able to do the same thing on your assignment. It also wants you to be able to take a table and a graph and list them out as ordered pairs. So we're going to do that first, and then we'll write our domain and range. So just listing these out in ordered pairs, that would be -7, 2, the ones right beside each other, -9, 5, and -11, 8. And then from there, I should be able to write my domain, my x values of each of those. My x values are -11, -9, and -7. My y values, 2, 5, 8. Again, listing out our ordered pairs, for example, for A is at -1, 2, x and y. B is at 3, 2. C is at 3, -3. D is at 3, -5. And E is at -1, -5. So if I want to list off my domain, that's all my x values. I have -1. We have 3 3s. You only need to list it once. 3 and -1. My y values. Well, my curly brackets are getting really bad. My y values, if I'm trying to write from least to greatest, I have a -5, another -5, -3, and 2. Now, we also need to be able to determine if a relation is a function. So I briefly mentioned this when we first started talking about functions, and then we've also used the vertical line test to prove if something's a function. In order to be a function, your inputs can only have one output. So if I see an x value that's listed twice but has different y's, then I know that's not a function. You cannot have multiple of the same x's with a different y. So deciding if example 5 is a function or not, we have to pay attention to our x's and see if any x's repeat. I have a 3, 2, another 3, and another 2. So I actually have 2 x's that repeat, and they do not have the same y's. So this is not a function. You cannot have those repeating x values. Example 6, I see again well, this time I don't have any repeating x's. All those x's are different, so it is a function. If these were to be graphed, example 6 would pass the vertical line test. You would be able to draw vertical lines without hitting multiple ones, but example 5 would not. And from a graph, it's the easiest one. You can draw vertical lines to see if I hit more than one point at a time. And I notice I hit in multiple places, so this is not a function. It does not pass the vertical line test. That's it for notes. I hope you all have an excellent day, and I will see you soon.